As I said in the previous chapter, one of the things you have to recognise about paper F1 is it's going to lead on to a lot of other papers. And particularly when we talk about systems, we are going to see these later on when you look at things like F8, P1, P7. So, systems. I'm going to talk about IT first of all. First of all, what do we mean by information technology? Information technology is basically any way that you get information into an organisation, do something with it, get it to the right people. Now, before we can talk about that, we'll need to talk about the difference between data and information. Data is simply a list of raw facts. That's all it is. It's a list of numbers. So, you can have continuous data, discrete data. Continuous data means it's constantly being measured. Discrete data means it's only got certain values. So, for example, if you are talking about how large the clothes are that you buy, small, medium, large, discrete things, it can only be in one of those three boxes. On the other hand, if you think about how tall you are, when you were born as a baby, you were that big, or that big, or that big, however big, you were that big. Now, you are that height. You have gone through every single possible height between what you were as a baby and what you were now. You didn't suddenly grow. You've had to go through every single possible value. Continuous data is where there's lots of different values. Discrete data is where there's only certain ones that you can have. We've got things like qualitative and quantitative. Quantitative, the second one there, means it's to do with numbers. It's to do with figures. It's a number, it's a percentage, it's a ratio, it's whatever. Qualitative is to do with words. How good was your lecturer? My lecturer was excellent. That's qualitative. How good was your lecturer? On a scale of 1 to 5, I would say they were a 4.5. That's now quantitative because it's a number. So most data we come across is numerical. Some data we come across will be written, and we need to be able to deal with both of them. Final two you've got there, primary and secondary. Primary and secondary simply means where does it come from? Primary, collected by us. Secondary, collected by somebody else. So I go to my students and I ask them how good the course has been. That's primary data because I collected it myself. The ACCA do a report that was published in the Student Accountant magazine, and it says, how good do you think your lecturers are at college? We did a survey. That's now secondary data because ACCA have collected it, not us. So if we collect it, it's primary. If somebody else collects it, it's secondary. Now, data then is just a list of raw facts. Information has been processed, so it's meaningful. Now, the example I always give of this is, imagine you work in a supermarket. You work in a supermarket, and there is a way of recording all the sales in your supermarket. So every time a customer comes in, you record every single item that they buy. Now, data simply means a list of every single item that they've bought. Somebody's bought some milk, somebody's bought some water, somebody's bought some cheese, etc., etc., etc. Now, you could print out that data. Here's a list of everything people have bought. The trouble is, it's not actually very useful. There'd be pages and pages and pages just of data. And what are you going to do with it? Information is where you've processed that data to be useful. And it might be useful if it's processed in different ways. Now, what I mean for that is, for example, is one way you could process the data is you could say, let's go through that data and let's pick out how often something is purchased. Now, that, of course, would tell you which products are the most popular. So that would now be information. That product is popular, so we need to have more of it. Exactly the same thing you could do is you could go through the entire set of data and say, let's have anything which has not been purchased at all. So here's a list of all the things we have in our store. Here's a list of all the things that have been purchased. Let's see if there's anything in the store that isn't bought by anybody. That's sometimes called an exception report. So it's a list of all the things that are missing. Now that would also be useful because it's now saying people don't buy these. So maybe we stop stocking them. Another way you could take exactly the same data is instead of looking at what people buy, you could look at when they buy it. Who would that be useful to? Well, that would be useful if you're thinking about staffing the shop. What time of the day do you need to have people there, and what time of the day do you not need to have people there? So there's lots of different ways that you can take the same data and process it in a way that's useful for different people. So when we're talking about data, when we turn it into information, the guiding principles of information is it has to be accurate. So that's obviously an acronym, which means it's going to stand for those letters are going to stand for various concepts. So first of all, it's got to be accurate. There is no point whatsoever in having information and it's wrong. You've collected some data, but you forgot to collect some other data. So we want to know what the most popular products are, and we've only got the data for half of the day. Well, what's the point in that then? Accurate. Similarly, has to be complete. So we have to make sure we've got the information for all of the day and it's been recorded accurately. Cost effective. It costs money to collect things. It costs money to collect data. We have to make sure that it's actually going to be something that we can then use. So cost effective. It's got to be understandable. One of the things that we often forget as accountants is that we are used to dealing with financial information. Other people might not be. Imagine, for example, you were doing paper F2 and you did an operating statement. If you remember an operating statement, you start with your budgeted profit, you do all your variances, you end up with your actual profit. Now, you know what that means. You know what it means by a fixed overhead capacity variance. If you simply printed that out and gave it to somebody else and said, look, there's all the variances, they might not have a clue what you're talking about. It wouldn't be understandable. So we need to make sure that whoever's getting this will understand what we're giving them. Relevant. It's got to be relevant to that person. Lots of people today in the information age have loads and loads and loads of information being thrown at them from various places. The more information you have, the more, to be honest, you may not be able to understand all of it. There may be too much. So only give people things that they actually need. How many of you at work get bombarded with emails that have got nothing to do with you? And the trouble is, it makes it hard to sort out the ones that are important because you're getting too many of them. So only give people numbers that they need. Adaptable. It will be nice to be able to take our data and process it in lots of different ways depending on who wants it. So I already said the data would be useful to see what's popular stock, what's unpopular, when it was purchased. We might take the same data and we might be able to look at who are we purchasing it from, who are our suppliers. The same data can be talked about, looked at in 4 or 5 different ways. That's adaptable. That's becoming very, very important to companies to have it be able to be flexible. Timely. Give the information to people when they can use it. There is no point whatsoever in saying, I will tell you which products are popular, but it's going to take me 2 years to do it. Well, what's the point of that? I want it now. I would rather have it now, even if it's not particularly accurate, rather than having it completely accurate and having to wait 9 months for it. Now, this is one of the big arguments between F2 and F3. F2 says, give me some approximate numbers today, rather than F3, which says, give me exactly the correct numbers and I'll wait for them. When you guys start talking about auditing, you will look at the fact that financial statements are often published 6, 7, 8, 9 months after the end of the year. It takes that long to make sure they're accurate. From a timely point of view, that's a waste of time. The year is gone and I'm still waiting on the financial statements. I've got to wait another 9 months to get them. Management accounting says, give me approximate figures, but give them to me now. There is a trade-off between those two. Final one, we've got there, easy to use. If you're going to use a computer program to process the numbers, then make sure it's easy to use. That's all. So information should be accurate. Sources. Where can it come from? Well, basically anywhere. The key thing to remember, and again, this is something that will become important at P3 as well as P5, is that in F2 and in F3, most of the information you get comes from inside. Inside the company, it's looking at things like debits, credits, stock purchases, inventory purchases rather. It's looking at all stuff to do with us. There's a lot of useful information that's outside the organisation, if only we went and got it. Things in newspapers that you think, well, that might be appropriate for us. Now, we've seen Anthony's triangle previously in the course. What we're talking about here is we're talking about the information that people need. You may remember, at the bottom, you have the people who actually carry out the functions and the operations of the whole organisation. I am at the bottom because I do the teaching. Strategic people at the top, they are the people who are on the board of directors who decide what the company's going to do next. What information do the people at the bottom need? Short term, I need to know how many people owe us money today. I need to know how much inventory we've got today. So it's short, it's detailed, because it's going to be relevant to a manager looking at one thing, looking at receivables, looking at payables, looking at inventory, looking at whatever it is. It will usually be pretty accurate, because it's usually dealing with things in the past. So we had somebody who bought from us, they have paid some money, what's left? So it's certain, because it's in the past. And we'll need that information regularly. People at the top, on the other hand, it will be summarised, it will be uncertain. Any of you that have done a net present value calculation in F2 will know that you're thinking about a long time, 4 or 5 years. You're making guesses because you're talking about the future. You don't actually have to do it very often. How often do you have to decide about a new project? Once every 3 or 4 years. So the information has got to be presented in an entirely different way for people at the top to the way it is at the bottom. Now, that follows on to what's called a system. A system means that we will have some ways of collecting all the data, doing something to it, and getting it to the right people. So we have to have a way of collecting all the debits and credits, processing them and thinking, well, how's that going to be useful to the person in charge of receivables or the person in charge of payables? Now, you can do it all by hand, but obviously that's going to be very time consuming. So there are some advantages of automating these things. So in other words, instead of keeping all your sales invoices, record them all on a PC, record them all on a computer, and then you can process them in different ways. How much was the invoice? When was the invoice? Who was it to? That's the same data, but we're looking at it in 3 different kinds of ways. If you did it manually, you'd have to add them all up separately. So you have to add up how much we spent, or you have to go through the invoices for this month and add up how much they are, or you have to look at a particular supplier and say how much do we owe them. Each time you've got to go back and do it again. Whereas with a computer, you just press a different button and it adds it up in a different way. So automating is good. You can see that it's faster, it's more accurate, you can do more. Hopefully, we'll cut down on the number of mistakes. It can be more complex. You can get the computer to look at every invoice from a particular supplier that is older than 3 months but less than 6 months, and the computer will do that. A human could do it, but it's much more likely to make a mistake. Presentation. Do we need it as a number? Do we want it as a pie chart? Do we want it as a graph? You know, you can do any of those things, but a human, you've got to do it in a different way. Now, of course, all of those are big advantages. The biggest problem with an IT system is simply the cost of setting it up in the first place. So you have to decide, is it actually worth it? Do you remember one of the accurate things for information, was it cost effective? Do we need to be able to analyse all of our supplier invoices in that much detail? Or do we simply know how much we owe people? So obviously that's for a company to decide. Now there's a number of different kinds of software, different kinds of programs you can get. And I do apologise, you've got lots of initials in this bit, but we'll work our way through. At the very bottom is what's called a TPS. A TPS simply records, there's the debits, there's the credits. There's all the things we've sold today in our supermarket. It's not actually very useful. But the trouble is, unless you do that, you can't do anything else. So it's like a basic one. It's a bit like if you remember Maslow. Maslow's basic needs. If you don't have them, you can't have anything else. Transaction processing, without that, nothing else will work. Office automation, you can see there, helps to increase the productivity. That's using things like word processing. So, typing things into a word processor is faster than getting people to type things on a typewriter or write them out by hand. The biggest thing is a lot of things you can just copy and do again. So sending out letters to customers is much easier with a word processor than writing more out by hand. Knowledge work. Knowledge work basically is a way that we can share information around the company. That would be something like an intranet. Or it might be something like a user group. I have just discovered something, I'm going to share my knowledge with you. Working our way up, an expert system. An expert system is a way of helping us to make decisions in the same way as an expert would make them. So in other words, what happens is we program a computer with the knowledge of an expert. If you find this, then that's going to happen. If this happens, then something else happens. So what we can do is we can perhaps think about somebody typing in the answers to lots of questions. What's this happening? What's happening here? What's going on there? And you get an answer for them. Now, it's not a very good example, but one example you could have of this would be something like advising somebody how to do a course. What course should you do? Should you do ACCA? Should you do CIMA? Should you do an MBA? Now, what you could have is you could send lots of people on training courses so that when a customer phones up, when a student phones up, you can say, you want to do this, do you? You want to do that. The trouble is that's expensive. So in effect what you do with an expert system is you take one person, program their knowledge into a computer. If that's what the student says, then I advise them this. If the student says that, then I advise them something else. Program it all in. And the great thing is then, whoever answers the phone doesn't actually have to know very much. I ask you this question, you tell me yes, I push a button and the computer then knows what question to ask next. At the end of all the questions, I can give you the advice. You should do ACCA. Now, that's quicker and it's cheaper than having lots of experts. So an expert system may be appropriate in some situations. Decision support system. That's something like a spreadsheet. A spreadsheet is useful because you can put in numbers that you think are going to happen and then you can change them. I think this product is going to sell for £10. So if we sell it for £10, we're going to sell 50,000 of them. Let's put that into a spreadsheet and let's see how much profit we'll make. Now let's see what happens if we change the price to 11. The demand will change to 45. Now let's see what happens. You can keep changing things. One of the things that's commonly done is a what-if analysis. What if I change that number? What if I change that number? What happens if I give our customers 60 days credit instead of 30 days credit? What will be the effect on my sales? What will be the effect on my cash flow? Spreadsheet can do it all very easily. An MIS. An MIS is very much aimed at the operational level. And it churns out lots of routine reports. This is what we were talking about at the bottom of Anthony's triangle. So in other words, what we're talking about there is we're talking about aged debtor reports, inventory level reports, things that are regular. They get churned out based on internal sources. And they let people make a decision, do I need to buy some more inventory? Do I need to phone that customer up and ask when they're going to send me some money? Final one we've got, ESSs. They are talking about the strategic level. Again, when we're talking about Anthony, they are often looking a long time ahead. They are often looking at things that are uncertain because we're not sure, because we're talking about the future. They don't happen that often. Those often use external pieces of information. What do we think the economy is going to do in the next 3 years and how will it affect us? How will it affect the sales of this new product? What happens if our rivals launch a product that's very similar to our one that's our best seller? So it's not using the same things. But these are all kinds of information and systems that we might have in an organisation. I'm afraid that you need to know all those names and know what they all do. On page 136, the final bit we've got in this chapter is talking about IT systems. Security. When we have got a computer system, particularly a transaction processing system, if it's damaged, in other words, the transactions get lost, we can't do anything. Imagine going into your F3 exam and you've got to try and do some work on preparing part of a balance sheet, and for some reason somebody's scribbled over all the numbers that you need. Well, you wouldn't be able to do anything. You couldn't do the question. Well, that's what we're talking about here. With a transaction processing system, that's the basic data that everything else comes from. MISs and all the rest of them are based on that transactions. If the transactions are lost, we can't do anything. So we need to make sure that our computer system is guarded against physical damage. Computers are fussy. If they get too hot, if they get too cold, if they get wet, then they will basically stop working. What happens if all of our transactions are stored on that computer and we can't get it to work? Human damage. That could be deliberate, going in and changing the numbers. There's an invoice for 1,000, I'll go in and change it to 100. So it could be deliberate, it could be accidental. Again, if we can't rely on the transactions, we can't do anything else, we can't run a company properly. Operational problems. It might be that our computer is adding things up in the wrong way. So we have said, add up all of the invoices for this particular customer, and perhaps we've programmed something wrong and it adds up all the invoices for a different customer. So actually it's giving us the right number, but it's answering the wrong question. So it's giving us the right number, but for the wrong customer. So it could be operational things. Now the big problem with operational problems is, of course, the fact that they're often very difficult to spot, particularly if the computer's doing something very complex. We probably don't understand what it's doing. We don't know what the right number is, so we don't know when it's wrong. And finally, data corruption. Again, what we're talking about there is we've got our data which has somehow perhaps been altered or perhaps has just disappeared. So it just is no longer there. We may have somebody who's hacked into our system and changed the numbers, or perhaps has, erased them. There is no information left at all. Final couple of bits, we've got spreadsheets and databases, because these are common things that are now used in organisations. A spreadsheet, and I'd be very surprised if you've never used a spreadsheet. Spreadsheets are used widely by finance because obviously they are particularly good for numerical things. They are simple, little training, widely recognised. There are certain spreadsheets, there are certain programs like Excel that are just known and used by millions upon millions of people around the world. And they're great, as I said earlier, for doing things like what if. They're great for just adding things up. They're great for doing simple calculations. The trouble is that they are not particularly flexible if you want to analyse the information in lots of different ways. So they're quite good for doing simple things, but if you've got hundreds of thousands of pieces of data that you want to analyse in lots of different ways, and remember, a company like a supermarket, if it records every single thing that it sells in every single store, we'll be getting millions of bits of data every single day. Spreadsheets just can't cope with that, it's too much. So databases are, it says, a collection of data which can then be manipulated. All that means is the data is all stored in one place and I can analyse it in different ways, so I can get bits of information from it. And the key things that we have here, the benefits, you only need to store the data once, so it doesn't need to be duplicated. It means that because of that, you only have to keep one set of data secure, rather than having lots of different spreadsheets that you've got to worry about. Greater flexibility. Spreadsheets are very, very flexible. But databases are even more flexible. You can do a lot more stuff with them. So we might not even know yet what we want to do with our data. And finally, consistency means that you can basically write a little database program so everybody uses it in the same way. So databases tend to have programs that you can write to get the data out. The only trouble with that is there will be issues with security because everything's in one place and everybody accesses it. Whereas with a spreadsheet, we might have lots of different spreadsheets, but with a database, everybody accesses the same one. So if it goes wrong for everybody. There is no privacy anymore, because everybody accesses the same thing. Databases are more complicated. Now, I can program a relatively sophisticated spreadsheet in Excel. I don't really understand how to do database programming. I'm trying to teach myself, but I don't really understand it yet. So the trouble is, spreadsheets, although they are not as complicated, they're very easy to get going with. Databases, you have to learn a lot before you can do anything. And they're more costly. So which one is better? It depends what you're going to use it for. A small company probably just does a spreadsheet. Large multinational, probably some kind of database. So in that particular chapter, we've talked about what kind of information you need. Is it data or is it information? How can IT help you? MISs, ESSs, etc., etc. And finally, the difference between a spreadsheet and a database.